Question number 4 is the number of complaints which a bank manager receives per day follows a Poisson distribution with parameter m is equals to 4. So parameter m is equals to 4. Find the probability that manager receives only 2 complaints on a given day. So if it follows, if x follows Poisson distribution with parameter 4, तो मैं इधर m की जगह पे से 4 लिख दूंगी. Now, by Poisson distribution, the function is e raised to minus m raised to x upon x factorial. The first case is only 2 complaints on a given day. So we have only 2 complaints on a given day. So probability x is equals to 2. It is e raised to minus 4, 4 raised to 2 upon 2 factorial. What is e raised to minus 4? It is 0.0183. 4 square is 16 upon 2 factorial is 2. We can solve this further. So 0.0183 into 16 divided by 2. Your answer is 0.1464. The next is at most 2 complaints on a given day. See, at most 2 means what? ज़्यादा से ज़्यादा 2 complaint होनी चाहिए. ये हो गया 2 complaint होनी चाहिए. This was exactly 2 complaints. So only 2. Exactly 2 means what? Only 2 complaints. But now we want that number of complaints should be at most 2, less than equal to 2. So less than equal to 2 का मतलब क्या है? It should be either no complaint or there should be only 1 complaint or there should be only 2 complaints. 2 का तो आ गया है, no complaint निकालेंगे हम लोग. X is equals to 0. E raised to minus 4, 4 raised to 0 upon 0 factorial. E raised to minus 4, that is 0.0183. P of x is equals to 1. E raised to minus 4, 4 raised to 1 upon 1 factorial. It is 0.0183 into 4. It is 0.732. Sorry, 0.0732. And P of x is equals to 2. We have already calculated it is 0.1464. So we will just add them. Your answer is so probability that x is less than equal to 2. It is 0.2379. At most का मतलब है ज्यादा से ज्यादा. जब वो बोलते हैं कि 2 होना चाहिए, at most 2 होना चाहिए, उसका मतलब ये है कि कंप्लेन जो है वो ज्यादा से ज्यादा 2 होनी चाहिए. मतलब एक तो वो 0 हो या 1 हो या 2 हो, नहीं तो उसके ऊपर नहीं जाएगा वो. So this is your answer. We'll go with question number 5. A car firm has 2 cars which are hired out day by day. Number of cars hired on a day follows Poisson distribution with mean 1.5. Find the probability that no car is used on a given day, some demand is refused on a given day. And they give you the value. Okay. So question number 5, they say that the car distribution follows Poisson. So let x follow Poisson with parameter 1.5. m is equals to 1.5. Probability will be e raised to minus m raised to x upon x factorial, that is e raised to minus 1.5, 1.5 raised to x upon x factorial. First case is they are saying that no car is used on a given day. मतलब एक पर्टिकुलर डे पे आपको डिमांड ही नहीं आई, एक भी कार यूज नहीं हो रही है, मतलब क्या प्रोबेबिलिटी दैट x इज इक्वल्स टू 0, डिमांड ही नहीं है एक भी दिन पे, दो ही कार्स है, दोनों भी कार यूज नहीं है, मतलब एक भी कार की डिमांड नहीं आई है कि नहीं, तो डिमांड कितनी है, 0 है. विल से लेट x be demand of car on a given day. अब वो कार यूज ही नहीं हुई है, मतलब क्या, डिमांड ही नहीं आई, मतलब x is equals to 0. So it is e raised to minus 1.5, 1.5 raised to 0 upon 0 factorial. So on a particular day, there is no demand. So this is the case. E raised to minus 1.5. E raised to minus 1.5 is 0.2231. They have given you the value. Now the second case is some demand is refused on a given day. कोई एक डिमांड गिवन डे पे रिफ्यूज हो रही है. अगर आपके पास दो कार है और अगर आप डिमांड को रिफ्यूज कर रहे हैं, मतलब आपके जो डिमांड है वो 2 से ज्यादा है, तो ही आप डिमांड को रिफ्यूज करेंगे. अब डिमांड 2 से ज्यादा है, मतलब डिमांड 3 हो सकते हैं, 4 हो सकते हैं, 5 हो सकते हैं, कोई भी हो सकते हैं. तो मतलब क्या कि डिमांड 2 ही है, उसका कॉम्प्लीमेंट, इट इज 1 माइनस p ऑफ x इज इक्वल्स टू 0, 1, 2. तो हम लोग निकालेंगे प्रोबेबिलिटी that x is equals to 0 or probability that x is equals to 1 or probability that x is equals to 2. E raised to minus 1.5, 1.5 raised to 0 upon 0 factorial plus e raised to minus 1.5, 1.5 raised to 1 upon 1 factorial plus e raised to minus 1.5, 1.5 raised to 2 upon 2 factorial. You can solve this. So if we find this, this will be 0.2231 plus 0.2231 into 1.5 plus 0.2231 into 2.25 upon 2. So this total will be 0.8087. So the probability of x is less, sorry, they have asked us greater than 2. Is 1 minus probability x is less than equal to 2. That will be 1 minus 0.8087. That is 0.1913. So this is when the demand is refused on a given day. Refused तब होगा जब 2 से ज्यादा डिमांड हो जाएगी, तब वो रिफ्यूज हो जाएगा. Question 6. Defects on plywood sheet occur at random with average of 1 defect per 50 square feet. Find probability that such a sheet has no defect, at least 1 defect. So they are saying that the defects are on an average of 1 defect per 50 square feet. So I will say let X denotes defects in sheet per 50 square feet. So X actually follows Poisson with parameter 1. So Poisson function is X is equals to e raised to minus m raised to x upon x factorial. That is e raised to minus 1 raised to x upon x factorial. The first one is no defect. So probability that there is no defect at all. X is equals to 0. It will be e raised to minus 1 raised to 0 upon 0 factorial. That is e raised to minus 1. That is 0.3678. Second, at least one defect. At least one defect मतलब क्या? Number of defects should be greater than or equal to 1. मतलब एक तो 1 हो या 2 हो या 3 हो या 4 हो या जो भी हो, लेकिन वो 1 से नीचे ना हो. So this is nothing but probability that x is less than 1 का complement. That is probability x is equals to 0 का complement. So that is 1 minus probability x is equals to 0. So 1 minus 0.3678. 1 minus 0.3678 is 0.6322. Question number 7 is also same. It is known that in a certain area of a large city, average number of rats per bungalow is 5. Assuming that number of rats follows Poisson distribution, find the probability that in a randomly selected bungalow, there are exactly 5 rats, more than 5, between 5 and 7, both inclusive. Okay. So we will say let X denotes number of rats in a bungalow. So obviously X follows Poisson with parameter 5. So probability is e raised to minus 5, 5 raised to x upon x factorial. Now first case, you want exactly 5 rats. So P of x equal to 5. So it will be e raised to minus 5, 5 raised to 5 upon 5 factorial. E raised to minus 5 is given 0.0067 into 5 raised to 5 is 625. Oh, sorry, 5 raised to 5 is 3125. 3125 upon 120. So you can solve this and find out the answer. It is 0.174 pi. Similarly, when they talk about more than 5 rats, the second case is more than 5 rats. मतलब number of rats जो x है वो 5 से ज्यादा होना चाहिए. तो number of rats ये 5 से ज्यादा होना चाहिए. तो ये 5 से ज्यादा होना चाहिए मतलब क्या? ये 6 होगा, 7 होगा, 8 होगा, या इंफिनिटी तक चलते जा सकता है. तो हम लोग बोलेंगे कि इट इज लेस देन इक्वल टू 5 का कॉम्प्लीमेंट. सो व्हाट इज x ऑफ लेस देन इक्वल टू 5? इट इज आइदर x इज इक्वल्स टू 0 और 1 और 2 और 3 और 4 or 5. So we will find all of them. X is equals to 0 plus probability that it is only 1 or it is only 2 or it is only 3 or it is only 4 or it is only 5. Find out all these probabilities, say -1, that will become the required probability 2. So more than 5 rats is less than or equal to 5 rats, वो आता है 0.6125, और फिर उसका कॉम्प्लीमेंट लेंगे तो 0.3875. This is more than 5 rats. Okay, then the next one. Between 5 and 7 rats, including both. I mean, they are saying the next one is probability that the number of rats are between 5 and 7, including both. So this is what we are talking about. So the rats can be 5, or they can be 6, or they can be 7. I think you can find out this e raised to minus 5, 5 raised to 5 upon 5 factorial, plus e raised to minus 5, 5 raised to 6 upon 6 factorial, plus e raised to minus 5, 5 raised to 7 upon 7 factorial. We can take e raised to minus 5, 5 raised to 5 upon 5 factorial common. It is 1 plus 5 upon 6 plus 7 5 square upon 7 into 6. And then we can solve this by putting the values. E raised to minus 5 is 0.0067. ये दी हुई होती है वैल्यू, ये हमको निकालनी नहीं है कभी भी. 3125 upon 120, and into bracket this will be, this is 7 into 6, that is nothing but 42. It is 42 plus 35 plus 25 upon 42. Equalizing the denominator, यहाँ पे 42 से multiply किया, यहाँ से 7, यहाँ पे 7 से, और इधर कुछ भी नहीं. Okay, now you can solve this and find out the answer. Your answer is so the answer is 0.42. If you multiply this and if you get it. If you don't want to do this, या फिर आपके पास इतना टाइम नहीं है एग्जाम में, तो आप यहाँ तक भी आंसर रखोगे तो भी चलेगा. You can keep it only till this. That is also okay. क्योंकि इतना कैलकुलेशन करने जितना टाइम भी होना चाहिए एग्जाम में हमारे पास. Okay. With this, we have finished with 8.4. Now there is only one exercise left. That is 8.2. 8.2 is actually about probability density function. जैसे हम लोगों ने दो वेरिएबल देखे थे, कंटिन्यूअस और डिस्क्रीट वेरिएबल. डिस्क्रीट वेरिएबल का प्रोबेबिलिटी मास फंक्शन था, उसके हम लोगों ने देख लिए प्रोबेबिलिटी मास फंक्शन, बाइनोमियल क्वेश्चन. अब है प्रोबेबिलिटी डेंसिटी फंक्शन. तो ये जो प्रोबेबिलिटी डेंसिटी फंक्शन होता है, ये बेसिकली तभी बनता है जब x, that is the random variable x, is continuous. So when random variable x is continuous, we get probability density function, जिसे PDF भी कहा जाता है. अब रैंडम वेरिएबल x अगर कंटिन्यूअस है, मतलब x जो है वो a और b के बीच में सारी वैल्यूज को अज्यूम करता है. मतलब it can assume a, a.1, a.2, so on up to b. It assumes in fact indefinite values in between a and b. और ये वैल्यूज इतनी छोटी छोटी होती है कि हम लोग हर एक वैल्यू की प्रोबेबिलिटी निकाले तो हर एक वैल्यू की प्रोबेबिलिटी तो निग्लिजिबल होगी, लेकिन ए और बी के बीच की जो प्रोबेबिलिटी होगी वो निग्लिजिबल नहीं होगी। ओके, वो काफी बड़ी हो सकती है। तो हम लोग इसकी प्रोबेबिलिटी निकालते कैसे हैं? तो हम लोग यहाँ पे प्रोबेबिलिटी फंक्शन ऐसा होता है, इंटीग्रेशन रनिंग फ्रॉम ए टू बी एफ ऑफ एक्स dx। यहाँ पे भी कंडीशन सेम है कि अगर ये प्रोबेबिलिटी है तो हर प्रोबेबिलिटी ग्रेटर देन 0 होनी चाहिए और टोटल प्रोबेबिलिटी 1 होनी चाहिए। जैसे एक्सपेक्टेड वैल्यू और वेरिएंस था हम लोगों के पास, वैसे इस प्रोबेबिलिटी डेंसिटी फंक्शन में भी एक्सपेक्टेड वैल्यू और वेरिएंस होगा, एंड आल्सो द क्यूमुलेटिव प्रोबेबिलिटी। Cumulative probability will be from addition of all the probabilities। तो ये जैसे जैसे आएगा हम लोग वैसे वैसे उसके formulas लिखेंगे and we will learn। So basically we should know that if x is a random continuous random variable, that is if x is of assuming values between a to b, then probability of x is equals to x is integration running from a to b f of x dx। We will learn all the formulas gradually।